Hey, welcome back to TechCon 2025 and welcome to day two. Thanks for rejoining. And I'm again Andy Harmon. I'll be the host today for the app dev and runtimes track. I think y'all are probably pretty familiar by now, but just a few reminders. If you want to submit your questions in the chat, we'd love to make this conversational. Also, a reminder at the end of the day, just like yesterday, we'll have an office hours where you can come on and even come off of mute and have a conversation, ask questions. So if you don't get a chance to post your question in the chat today, feel free to join us at 2:30 Eastern time, where many of our speakers will be available to answer questions live. With that, I want to dig right back into the exciting new content. We've got Graham and Louisa to join us this morning and kick us off. And we're going to dive deeper into our new SaaS platform, EASeJ. So with that, Louisa, over to you.
Thanks, Andy. Hi, everyone. Delighted to have you with us today. As Andy said, my name's Louisa Gillies, and I head up product management for the new IBM Enterprise Application Service for Java, or EASeJ, as it's affectionately known. Graham and I are going to take you through a bit of a deep dive. Just a couple of notes, though, before we get going on it. This service is currently under limited availability with a view to becoming publicly available later in the quarter. So I'm really excited to introduce you to the service and to launch it in the coming months. I'm going to cover a little bit of context before I pass over to Graham, just to help you understand where this fits in our portfolio and kind of how we've come to do it. So if you could move to the next chart, please, Graham, let's kick straight off. So as I'm sure you're aware, there's a critical shift coming in 2026, and that's the end of community support for Java 8, meaning that many popular open source frameworks are no longer going to provide security updates for Java 8. And on top of that, major vendors like Oracle and Broadcom have yet to provide, very clear guidance on a long-term path for Java 8. So, we know this puts your organization at risk of not just cybersecurity exposures, but operational failures and much more. And for many, the manual methods of moving off of Java 8 have just not been cost effective or fast enough. And in fact, in our experience, it can take about 700 hours to upgrade an application without using the right automation tooling. And if you have hundreds of those applications, that can take a team of engineers years and years to execute. But don't worry, IBM has solutions to overcome the issues, and we've really been trying to make sure we can help you make the transition very stress-free. So to set the context, if you will, we've just launched a new portfolio that gives you much more flexibility to decide how to respond to this kind of upcoming event. The portfolio is called the IBM JSphere Suite for Java, and it gives you options. It gives you options to keep your applications in Java 8. It gives you options to upgrade to Java 17 and beyond, while maintaining your existing WAS console and scripts. Or we can help you move those applications to the cloud, either on Java 8 as a stepping stone to Java 17, or right to Java 17. Okay, Graham, if you could move to the next chart, please. One very important thing to consider is that as you move your application estate forward, you will almost certainly need different strategies for different applications. Some of them you may want to keep going along in Java 8, but just get support. Others you may want to upgrade to take advantage of new features and performance improvements, but as I said, keep them within your existing WebSphere environment. While others you may want to move to a managed service in the cloud to reduce that maintenance and management burden that you currently experience. At IBM, our approach is very simple: to allow you to upgrade what you need to, when you need to, so that you can stay secure and ready for the future without unnecessary hassle. Okay, Graham, if you can move to the next chart, please. Let's talk a little bit about how IBM actually does that. Years and years of client engagements around modernizing applications have helped us to build a simple process that's powered by automation and AI tools. We start with an in-depth analysis of your entire Java application estate, including dependencies like databases and messaging. Our discovery tooling helps you to visualize your estate in a very simple way, so that you can review and prioritize where to start, and then it can create a tailored migration plan for you with automated steps and guidance. Once you have that plan, you have the assets you need to start migrating applications to your desired destinations. And then you can use our generative AI-based tools with the Watson Code Assistant product to help generate code to make those code changes faster and to accelerate the process even further. So, whether you're staying on Java 8, upgrading your Java version, or adopting a cloud-based solution, we've got some options that can help you to minimize the cost and risk of that migration. If you move to the next chart, please, Graham. Our new JSphere suite offers a range of products that can align with your goals and strategy to make that modernization more flexible. This table is just a quick breakdown of the key components that make up the suite and the strategies that they support. So, for example, if you want to stay on Java 8 but ensure support, you would take our new open source library support for Java offering. If you want to upgrade Java while staying in your existing WebSphere environment, you'd take the new modernized runtime extension for Java. Or if you want to move to cloud, you can adopt containers or microservices with Liberty, or you can move to our new managed service, Enterprise Application Service for Java. A key advantage of our approach is that automation tooling that I mentioned, and you can see the results that we can achieve in the time savings row, and then you can contrast that obviously with the transformative potential to your organization. But the point is, with JSphere Suite, you can modernize at your own pace, you can choose the level of transformation that you want to take on, and also the amount of effort that works best for your business. So next chart, please, Graham. As I mentioned, the focus of this talk is going to be on EASeJ, because we know that that can bring you a high transformative benefit. But before we go into that, we'd like to just take a quick poll, if you're amenable to it, of the kind of application modernization strategies that apply best to your WebSphere applications. So when the poll pops up, if you could select, I think you can only select one, but if you could choose the option that applies best for you, we'd really appreciate it and be very interested in the results. So I'm assuming that's gone up, but if not, I will just introduce Graham whilst you're filling that in. Graham, over to you.
Okay, thanks, Louisa. So yeah, as Andy mentioned, my name's Graham Charters. I'm a senior technical staff member at IBM, and I'm in Louisa's product management team, mainly focused on the kind of technical aspects of EASeJ, or Enterprise Application Service for Java. So what I'd like to do is take you through some slides that kind of motivate why you might want to choose a managed or a cloud managed Java application platform, such as Enterprise Application Service for Java. And then I'll go into some more details on EASeJ itself, talk a bit about the modernization tooling that Louisa mentioned that helps you get from where you are today with your existing enterprise applications running on traditional WebSphere or other Java EE application servers to get those to the EASeJ cloud service. And then I'll finish up with a demo and then just a final couple of slides to round things out. So we talked about, Louisa's introduced the portfolio. One of those items is EASeJ, a cloud managed application platform. But why might you want to choose that? And I think the kind of at the heart of it is how much infrastructure do you actually want to be responsible for? So you probably know how much you're responsible for today, but how much do you really want to be responsible for? So if you look at what it takes to actually run an application, we often think, well, it's just an application. I've got this Java EE application or however it's been written, and it's or a Spring application, and I've got it deployed in my data center. But when you actually drill down on the details, there's lots of things that have to line up in order for that application to run. All the way from the underlying hardware, the operating systems, virtualization. You eventually get up to the virtual machine, that you're running for the application, or maybe it's a container, and you've got again another operating system layer in there. You've got Java, the runtime, you've got the work you need to do do entitlement tracking and billing, and then you're kind of getting close to the application. You've got the build and the deployment capabilities, and eventually you reach your application. And this is just an example set of things. I'm sure there are other things I've not included here. And it's not just a case that you've got this stack of things. Each of those things has its own life cycle. So you need to discover them, learn about them, evaluate them. You might run POTs, POCs to check that they are what you want to use. You've got to then buy them, provision them, configure them, integrate them, observe them, patch them, do version to version upgrades, and then eventually you might retire the technology sometime in the future. And of course, it's not just about the application. Your application, if your applications just existed in isolation, they wouldn't be very interesting applications. They'd have no stateful data. They wouldn't be able to communicate with other systems. So it's actually a workload you need to think about. There's the application, there's the MQ. If you're using IBM MQ, there's the MQ deployment and integration. If you're using a database, DB2 for example, then there's the database. And again, they have their own stacks, and they each of those components within those stacks have their own life cycle. But when you take a step back and think about it, what is it that actually differentiates you as a business? It's the application. That's what you truly care about. That's what if it's a customer-facing application, that's what your customers see and experience. They care about the capabilities that application has. They care about the availability of that application, and those things directly affect the bottom line of your business. And everything else is really a means to an end for delivering those experiences and capabilities to your customer. So how can cloud help with all of those things in the stack? So let's start with how things look on premise or on premises. So red we're using to represent cloud managed, blue we're using to represent vendor managed. So on premises, of course, you own the lot. It's in your data center, you own the hardware, operating system, etc. So it's as we've just discussed on the previous slides. And I've got options when I move to the cloud. I might choose to rehost and run in VMs. I might choose to run on a managed cloud Kubernetes service like IKS or EKS or AKS, or I might run in a managed OpenShift environment like ROX or ARO or ROSA. Or I could even choose to run in a containers as a service environment, maybe Code Engine, Azure Container Apps, and I've just gone out of my head the AWS equivalent. And they do help. You can see that a number of the layers have been taken over, or the responsibility has been taken from us, and is being provided by the cloud, which is great. But there are still some challenges associated with that. So let's say, for example, we're doing the kind of most popular route, and or one of the most popular routes, and we've gone down the Kubernetes route. So yes, the cloud is going to manage that technology for me, manage that Kubernetes environment, but I'm responsible for using that environment, using Kubernetes. And it's well documented that there are kind of skills challenges associated with that. I've just picked a few surveys over the past couple of years to kind of highlight some of the challenges in terms of complexity and lack of skills being an inhibitor to adoption of Kubernetes. Lack of talent being a challenge for enterprises, and it went up from 4th place. I think this is a 2022 survey, so went up from 4th place in 21 to 2nd place in 2022, and that's because Kubernetes became more popular and the skills growth hasn't kept up with the growing demand for Kubernetes. And then there's the Red Hat survey, which is showing that one of the challenges with having one of the issues with having challenges around Kubernetes skills is it's not just, oh well, I can't do something. You may actually try and do something with Kubernetes and then end up, if you misconfigure the environment because you don't have the deep technical skills you need, then that can result in security exposures. So we've talked about how cloud can help and shown the kind of Kubernetes story, and talked a bit about the challenges around Kubernetes. Those challenges are going to be primarily on the kind of operations side. But how does the adoption of a kind of Kubernetes platform, a managed platform such as Kubernetes, affect the developers as well in terms of their experiences of the world? So if we look back to how applications were traditionally delivered, and some customers are still doing this today, and that's perfectly fine. What I typically have seen is that the developers are responsible for developing the application, and they build that application, and then they throw it over the wall to the operations team. They provide the WAR file or the EAR file, and they provide some instructions on how to configure the application and so on. And then the operations team are responsible for all of the infrastructure, and they're responsible for deploying the application into production, monitoring that application, making sure it's available and being called out at the weekends when something goes wrong. And the development team are quite happy because they threw it over the wall and all is good. The operations team, they're sweating a little bit because they've got lots of responsibilities, and there are probably people on this call who know this experience, where the development team will often kind of dissipate over time and sometimes disappear entirely, and the operations team are left holding this application baby and kind of challenged as to what to do with that going forward. If we look at the kind of modern delivery experience, so here we've got a Kubernetes environment that's being adopted by the operations team, and they're maybe looking a little bit puzzled because they're having to grow those Kubernetes skills. On the development side, essentially the bar has been lowered or raised. Essentially, they own more of the items in terms of the delivery. They become a multidisciplinary team. They're responsible, if we're talking Kubernetes, they're responsible for the container, which has a guest operating system. It has Java, it has runtime. They're responsible for ensuring jointly between the dev and ops that entitlement tracking and billing is working okay. They're responsible for the build of the application, the deployment of the application, and then the application itself. And they're also responsible for that then in production. So they're the people now getting called out when something goes wrong. So you can see they're sweating because of all these additional responsibilities. And those dev teams, they went into development for a world on the left-hand side. They did not buy into the world on the right-hand side. That was not what they were expecting when they started coding 5-10 years ago. And it's well documented about these challenges for developers. On the left-hand side, this is an example which basically is pointing out that cognitive load, all of those technologies and that they now need to understand and be responsible for, is a real challenge for those people. It's a source of angst. It's a source of low productivity. And then when we look at the kind of day-to-day life of a developer, you can see that developers are involved in a lot more things now than just writing the code and delivering those applications, and that's a drain on them in terms of forward development for those applications, and that's a drain on the enterprise in terms of new capabilities and innovations going into those applications in order to differentiate the company. So one of the things you might be saying is, okay, well, platform engineering is here to address that challenge, and it does help. It absolutely helps in terms of the division of responsibilities. So platform engineering is all about setting up or having a different organization within the enterprise that's responsible for providing platforms to the development teams. So it's about maybe, for example, providing a platform which comes with build and deployment capability, and it provides the runtime for a certain class of applications. It might be enterprise Java applications, for example. It comes integrated with the observability and so on, so that the application teams don't have to have those responsibilities now. They develop the application, they use the platform to deliver that application into staging, production, and so on. They're still responsible for monitoring that thing and its availability in production, but they don't have those infrastructure responsibilities now. And you can see we kind of got all three teams happy now. The application team have a containable amount of responsibility. The platform engineering team are happy with the scope of their responsibilities, and the ops team have built up their skills on Kubernetes. But if we look at platform engineering, what those teams need to do, there's still a lot of things they need to be responsible for. There's a lot goes into providing an integrated developer platform, or an internal developer platform for those application teams, and they need to maintain all of these technologies and provide the end-to-end DevOps lifecycle for the application teams to deliver their applications. And actually, if you take a step back, we've not changed the equation for the enterprise as a whole. The enterprise is still responsible for all those red pieces, even if you're using a managed environment in the cloud and providing your own internal developer platform. So can we go further? Yes, there are other things in cloud concepts of FaaS and application platform as a service and SaaS and so on. And if we look at the kind of the options out there, what we find is you can get to the point where maybe you're bringing your code, your application, and there's an environment which will run that application, but often you're still responsible for the kind of entitlement billing side of things. And also responsible for the application build and application deployment. There are some environments that might take a little bit further, but really the question is, how do we get further? Can we get to that nirvana essentially, where you can bring your application, bring some configuration that describes how you want that application to run, and everything else is provided for you? And so this is where Enterprise Application Service for Java, or EASeJ, comes in. It's a cloud-managed Java application with application platform that brings the tool, that also provides tools to help you bring your existing applications to the environment safely and cost effectively. And I'll talk a bit about that after I've done the kind of intro to EASeJ. So I like to think of Enterprise Application Service for Java in terms of kind of three capabilities. One is kind of a large part of what I've just been talking about, which is eliminating the cost and burden of managing all that infrastructure, all that middleware, and so on. I like to think about you think about what's the difference between on-premise versus cloud. For me, it's really about who manages the stuff. So when it's on-prem, you're managing all the infrastructure. When it's in the cloud, somebody else is managing stuff for you. So if that's the distinction, then I like to think that the ultimate goal of moving to the cloud should be to have the cloud provider or the cloud services manage as much of your stuff as possible, so you can just focus on the things that differentiate you. And so that is the first primary goal with Enterprise Application Service for Java, and managing that infrastructure in a way that gives you high availability for your applications, zero downtime when you're updating applications, and an SLA of 99.95%, which I think equates to something like 20 minutes in a year. The other, so if you're running applications on Enterprise Application Service for Java or EASeJ, you want those applications, if you're bringing applications to it, you might want to bring your existing monolithic applications, you might want to develop new applications. You need that application, you need EASeJ to provide you with a modern experience, a modern way of delivering applications, and support a modern architecture for applications. So EASeJ is designed to run monolithic applications very, very well. So traditional applications that have come from your enterprise, you maybe developed them 10, 20, 25 years ago. But give you a modern delivery experience for those applications, but also let you refactor those applications into microservices, or indeed create new modern cloud native microservices. So EASeJ has a built-in CI/CD capability. It's got built-in build pipeline, built-in deploy pipeline, and that's all integrated into GitHub through a best practice GitOps experience. And I'll talk a little bit more about that in a subsequent slide, about how we essentially drive EASeJ through the normal practices of a developer working in Git. And of course, as I said, you might want to refactor applications into microservices, maybe expose them as APIs, and we have the APIs as part of EASeJ to be able to do that, publish them using open API definitions, or maybe make them event-driven. And we have the capabilities to do event-driven applications as part of EASeJ as well. So if those first two reasons or two value propositions for EASeJ are interesting, you might want to understand how to get there. That's the third value proposition. EASeJ comes with modernization, migration tooling that helps take out the guesswork of migrations. We've spoken to customers a lot about their challenges. And one of the key challenges, it's not just about migrating the application, it's about understanding the workload, as we talked about it previously, and being able to move the application and understand the impact of moving that application on your messaging and your database, and whether you want to migrate those as well into your destination. Also, if there are any code changes associated with that, we've done for many years a very good job of doing deterministic code changes, and we've been evolving those over the years in terms of, for example, providing rules to map from old code to new code. But if there isn't, if there are code changes required that aren't deterministic in that way, then you need to use some kind of generative AI capability. So we've been working to enhance watsonx Code Assistant to again enhance that migration experience and make it quicker and cheaper for you to do that. Okay, so next level of detail on Enterprise Application Service for Java. I should just keep calling it EASeJ. So I like to think about, when I think about the technologies we provide, I like to think about them in terms of the DevOps lifecycle. There are 8 phases to the DevOps lifecycle. I'm showing 6 here because the plan and release phases aren't really things that are relevant to the technology. They're more kind of human related exercises. So we've got the kind of 6 that are relevant. We've got code, so writing the application, building, testing, deploying it, operating it, which is essentially running it, and then monitoring, which is really all about observing it. And then from those observations, you go back around that loop, you make code changes and build, test, etc., etc. It is a life cycle that you continually loop around. So how does EASeJ help with this life cycle? So on the coding side, we provide standard APIs and the developer experience. EASeJ is based around Liberty, so we already have the Liberty tools as a rapid developer experience for developing your applications. Because it's based around Liberty, we have that API compatibility, which helps with modernizing and migrating your code. It minimizes the code changes you need to make in order to get the application to run in this modern cloud environment. And as I mentioned, we've got the watsonx Code Assistant capabilities that don't just help with that migration, they also help with ongoing code development. On the build side of things, I talked about we've got the built-in CI pipeline. So based on your code changes that you make in Git, we can trigger a build. That can be a personal build for an individual developer, or when you merge your code in, that can be a build that runs the tests and so on and creates the artifacts ready for a release to be deployed into an environment. As part of that build, we care a lot about security. One of the things we've done is provided a built-in SALSA capability. SALSA is a standard for build environments to give you provenance for your builds. So this is all about protecting against supply chain attacks. So that the SALSA file that we produce as part of the build file, it tells you where the application was built and about the provenance of it. So in other words, it was built by EASeJ, which is a protected build system, but it also lists out the individual artifacts that went in to produce your application, along with the signatures for those artifacts. So if there is an issue with some kind of supply chain attack, you can look at your SALSA files and understand whether your applications are affected and then determine what resolutions you need to take. We also automatically store all the artifacts for up to 12 months. So if you've deployed into an environment, into production, for example, we will keep those artifacts for as long as you're in production, and then once you undeploy from production, we'll keep them for a further 12 months in case you need them. Maybe you want to redeploy, for example. On the testing side, we run tests as part of the life cycle. We run tests when you run a personal build, or tests when you run a release build. And also we have the ability as part of Liberty to run contract testing. So if you're exposing APIs, for example, you can use Pact to run contract tests to ensure you're not breaking the consumers of your APIs. On the deployment side, as I mentioned, we have as part of the GitOps experience, you have a configuration file or configuration files in Git that describe your deployments. Changes to those trigger the deploy pipeline that then deploy into one of 2 pre-built environments in EASeJ. So you can deploy into a staging environment or a simple or a production environment. And as we do those deployments, we do a rolling update. So we start the new instance before we take the old instance away, or old instances away, in order to preserve your availability. In terms of operate, we run it's running in a cloud environment. We automatically distribute the application instances across the availability zones. So the regions that we're in, or the region we're in, has 3 availability zones. If I choose to deploy 2 instances, those instances will be in 2 of those availability zones. If I deploy 3, it's in 3. If I do deploy 6 instances, I'll end up with 2 in each of those availability zones. And you can specify a minimum number of instances, a maximum number of instances, and then dynamically scale up and down. This is also, and I should have this in this slide, it's also a single tenant environment, so you're isolated from other users of the cloud service. And the instances have a 99.95 SLA, as I mentioned previously. Then on the monitoring side, we have simple integration with the monitoring and logging capabilities of the cloud. So we integrate with IBM Cloud Logs, IBM Cloud Monitoring. So you can actually get a kind of persistent representation of the information that we've produced as your application instances have been running. You can set up alerts, so you're notified if any issues happen. And we're also in conjunction with the MQ and DB2 cloud services. We're consistent in terms of the observability technologies we support in terms of cloud logs and monitoring. So you can stand up a single instance of cloud logs, a single instance of cloud monitoring, and have all the information come from the 3 services and see the kind of end-to-end observability experience. Okay, so how does the EASeJ actually work? I talked about the kind of GitOps experience, or the GitOps workflow that we have as part of this. So on the left-hand side, we've got the development flow, and on the right-hand side, we've got the deployment flow. And so the way it works is you have a source code repository for your application code. And if somebody wants to make a code change, then they'll create a branch. And so they'll do their work in that branch. So main is where all the code, the kind of core code lives, in terms of that's the code that will end up being released, or release builds will be created from. So I'm a developer. I've created my branch. I'm doing my code changes, and I'm happy that I've got to a reasonable point. So I've committed and pushed my changes, and I'm now going to create a pull request. When I create my pull request, so I've maybe built it and tested it locally. I created my pull request now, and that's resulted in a pull request build being done by EASeJ. I'll go and check that pull request build. I'll see that the tests have run okay, everything's fine. So I'll now ask a peer of my organization, of my team, maybe my team lead, the lead developer, to go and merge my changes in. So they'll review that pull request build, check that they're happy with everything, check that they're happy with the code, and then they'll merge that into the main branch. And when they do that merge, that triggers again a release, a build in EASeJ, which we call a release build. And so when that build runs and completes, there will be the application artifact created, a bunch of other artifacts. There'll be the test results, and you've now got a candidate that's ready for putting into the staging or production environment. So we're now over onto the right-hand side of the branch of the slide, and so for EASeJ, you also have a configuration repository. That configuration repository contains the staging environment configuration and the production environment configuration. And so what I can do is as a deployer, maybe the lead developer or an SRE looking to deploy the application, that release that's being built, I create a branch. I make my configuration changes to reference that new release build. And what I can do is then commit and push my changes and create a pull release for those changes. And what that does is then trigger what we call the configuration validation build in EASeJ. And EASeJ checks that configuration is correct and everything's good. And then again, we would get a peer person to review those changes and merge that configuration in. And once that configuration is merged in, that triggers what we call a deployment job. And that is going to deploy into either the staging or the production environment, depending on which file we changed. So that's essentially it. That's the workflow for working with EASeJ, both from a developer experience but also an operations experience. But I talked about workloads at the start. So what about databases and messaging? So we didn't create EASeJ in isolation. We worked in collaboration with the MQ team, the MQ cloud service team, and the DB2 team. And so out there we have MQ as a service. I didn't mention it on the previous slide. It was on the previous slide in terms of subscription billing. We have consistent billing approach across the EASeJ service, the MQ as a service, and DB2 as a service. They're all single tenant, all available in the same cloud region. And so MQ as a service gives you exactly what you'd expect from an MQ service. You can stand up queues and queue managers in a reserved instance infrastructure to run your high available, reliable messaging. And then again, DB2 as a service again gives you what you'd expect from DB2 in the cloud. So being able to run high available DB2 instances, single tenant instances in the cloud. Okay, so that's the kind of intro to EASeJ and also a little bit on the kind of database and MQ support. So how do I bring my existing applications over? So maybe you like what you see and you're wondering about how to bring you've got a traditional WebSphere application you're thinking might be a good candidate to bring across. So we've done a lot of work over the past year in our modernization, our migration tools. Maybe if you saw the session yesterday from Dana, then you'll have seen quite a bit of this, which is great. I can do a refresher, but also a refresher specific to EASeJ. So what we've done is we've enhanced the discovery aspects of our modernization tool. So with Application Modernization Accelerator, you can not only discover your application workloads, but you can discover the dependencies. So what databases does my application depend on? And if it's DB2, we can scan that further to provide further assistance with migration of your DB2 instances into the DB2 as a service. What are my MQ dependencies and so on? So you can scan all of those things and discover your application workloads. You can visualize all those dependencies, and there's also additional data, and I'll do a quick demo to show that that helps you make your decision and plan what you want to do in terms of migration. We then generate what's called a migration bundle that helps that you would give to your MQ admin, your DB2 admin, in order to do their migrations, and you give to your application team in order for them to migrate their application code, and they would execute their migrations. Also, as part of the tools, and I'll just kind of show you where it is in the tool, there's the ability to, from within the tool, stand up a project in the cloud environment and stand up instances of the services ready to receive the data, receive the MQ configuration, and receive your application. So how do those tools work? I've kind of talked a little bit to this already. We think of it in terms of 5 phases. Discovery, which is all about discovering the workloads, as I talked about. Visualization and drilling down on the details. Planning your migration, so making your choice as to what you want to move across, so the application and then perhaps its dependencies. Reviewing and the ability to customize that plan if you want to, if you change your mind about bringing across an MQ dependency or a DB2 dependency and so on, and then eventually executing, generating that plan and then executing that migration. So I'm going to switch to my browser. Hopefully I'm sharing my screen, so this should work. I'm sharing my whole screen, so I'll probably make it a little bit bigger so you're not missing out on some real estate. So this is an instance of the Application Modernization Accelerator tooling, and you have the concept of workspaces. These are places where you're essentially working. It's got data that's been imported from discoveries, and where you're going to work on a migration project. So these could be individual migration projects that you're working on maybe as a team. So I'm going to go into the demo data one, and I'll start with the visualization. So this is kind of, when people see this, they're often kind of, blown away by it, because before we had this capability, you're essentially blind to what it is your application depends on. So it can be a little bit, there's a lot of guesswork, and it can be a bit hit and miss in terms of choosing what to migrate, and then maybe later discovering that there's an application or a database dependency you weren't aware of or you'd forgotten about. So we can look at different applications and their dependencies. We can look at database details and see what applications depend on those databases, for example. I'm going to pick the mod resorts application eventually. So let's have a look at mod resorts. It's got an MQ dependency. It's got a database dependency. You can see what it was that caused that dependency. So this is the configuration that was discovered for that dependency. We can see the configuration for the MQ dependency as well. So you've got an idea about why these relationships are being shown as well. I can use the search to filter, for example. So actually, I'm doing mod res. I've already got that one selected. If I didn't have it selected and I did this, then it would highlight that. So I can then go into a more detailed assessment of all the things that are part of this workspace, and a more detailed assessment on the thing that I think I'm going to choose to migrate. So, for example, let's just not look at mod resorts just a second. One of the things that the tools do is understand about common code. So other dependencies that are shared between different applications. So if you tackle common code first, then that's a cost that's taken away from a number of applications, which is valuable in terms of understanding your planning. So we show how complicated or how much effort is required in order to migrate the different applications, what the tasks are that are required, so and how many of those tasks are, how much automation there is. So mod resorts looks like a good example, because although it's saying there are 2 things I need to change that need to be addressed, there are automated changes for those, and it reckons it's about half a day's worth of effort in order to migrate this application to EASeJ. So we can pick that application, take a bit more detailed look at it, see the MQ dependencies, the DB2 dependencies. We can look at the code changes that are required. We can look at the automation. So, for example, if I want to do these code changes as part of a build, I can use the Open Rewrite plugin to map these changes, or I can take my migration plan from this tool and import it into watsonx Code Assistant, and that provides a very, very simple way of applying these code changes in the watsonx Code Assistant tool. And so eventually I've decided this is what I want to do. I'm happy with all the things that I'll need to do in terms of changes. And then I can go and view the migration plan. This gives me the instructions and some guidance on how to migrate the MQ and DB2, and also how to migrate the application to EASeJ. And I can then download that migration plan, and that's what I will share with my MQ, as I said, my MQ admin, DB2 admin, and my development team. But I can also, as I mentioned, I can just start the process in the cloud. So I can, from here, sign into IBM Cloud, create a new project, and it will stand up, as long as I own the subscriptions for MQ as a service, DB2 as a service, and EASeJ, it will stand up a service instance for each of those, ready to receive the migrated database, MQ, and application. Okay, so that's the demo for the tools. I'll now just do a quick demo of EASeJ. Just keeping my eye on time. I'm just going to sign into my instance. Okay, so you may recall the where I showed the GitOps experience, and on the left-hand side we had the developer experience, on the right-hand side we had the operations experience, and so that's how this menu is laid out. So on the development side, I mentioned about doing pull requests. This is where we can see pull request builds, and then when you merge a pull request, you get a release build. So this is where we can see release builds. I can see whether this one's been deployed into staging or production. On the right-hand side of that slide, that's where I said if you do a pull request, you get a configuration validation build, and we can see an example of that. And then if you merge that configuration, you can see we do deployment jobs, and we can see the results of deployment jobs. And of course, a deployment job deploys into an environment, so we can see the staging environment. We can see we've got one instance running. We can go and take a look at the application that's running in that staging environment. Everything looks good. Fancy a trip to Las Vegas. Let's go and check. Yeah, nice weather. And then we can again do the same for the production environment. Okay, and so I mentioned that each of these pieces of lifecycle are essentially triggered from an experience in Git. So I have a source repository and I have a configuration repository. In the source repository, we can see the code. This is the code for the application. I've already got a pull request that I created that's ready. So I'm just going to merge that pull request, and that will trigger a release build. Similarly, I've already got a pull request for the configuration repository. We can go and look at the changes that I did for that. So I've just basically updated the version, and so we can. So I can go and merge that, and that will again kick off a deployment job. So if I go back to my instance of EASeJ, I can see I should now have a release build running. Oh no, did I merge? Did I not complete that? No, I didn't complete it. There we go. Oh, interesting. Let me create a new one. All right, let's try that again. So I'm just going to create a code change. Ooh, that's interesting. Is Git being a bit naughty to me? I'm going to commit this directly and then see if that works. Oh, well, that worked. So I think maybe I needed to refresh my browser. Oh, this one was merged. OK. All right. So that was the configuration change. So that will have kicked off a deployment job. So we can go and look at. So I should have. Oh no, I didn't do a pull request this time. So yeah, you can see the release build has been kicked off. It's just started now. And if I go and look at deployments, we should see, hopefully, did that one actually merge OK? It said it did. Okay. Oh, well. What was that? OK, let's do a different change. So what I'm going to do is I'm going to promote this one to staging. And the way we've designed EASeJ is we don't have write access to the Git repositories because a lot of enterprises won't allow write access to their source and configuration repositories. So what we do is we provide simple instructions on how to do the deployment into staging. So the deployment is essentially update this version within the environment YAML. So I'm going to go into the configuration repository. And edit the staging environment YAML. I'm also going to decide, actually, I want to vary between, actually, I'm going to have minimum of 2 instances and maximum of 3. So I'll commit my changes. I won't create a branch so I can see the deployment kicked off straight away. And you can set up GitHub to require you to work through with branches and pull requests, and that would be what we would expect most people to do. But just for demo reasons, I'm not doing that part of the process. And so we can see that's kicked off a deployment job. We could go and look at the details. There's not a lot there at the moment because the deployment's just started. But I can look at other deployments that have happened previously and see the details of those. Again, I mentioned about release builds. We can go and look at a release build, for example, and see the details of the release build. And we can see the test results that were run as part of this release build, and we can go and see all the artifacts. And I mentioned about the salsa provenance file. This is the application that's being deployed, server configuration, and so on. Okay, so that's the EASeJ demo. I'm just going to go back to the slides. All right, so I just want to kind of highlight some of the benefits of using EASeJ over maybe a custom-built solution that you might have or might be thinking about creating. So in terms of what benefits in terms of onboarding developers, if you build a custom environment, there's the need to skill them up on each of the individual parts of the tool chain. I think because EASeJ is essentially an end-to-end experience, there's a smaller surface area to understand because it's essentially tailored specifically for a delivery of enterprise Java applications. So it's easier to onboard new developers into that environment. Maybe you need to upgrade your CI/CD tooling over time, maybe do version-to-version upgrades. You would have to do that if you own that capability. With EASeJ, that's all built in as part of the experience. We do come across customers when we're talking about EASeJ where they say, oh, well, I already have a CI/CD capability. We enable you to bring your own CI capability, and we're looking at enabling you to bring your own CD capability. So if you just want to use the run piece, have us manage your applications in the environments, then that will be an option, and you can basically reuse your existing CI/CD pipelines. Maybe CISO requires you to provide an SBOM or a salsa report for your applications in order for you to understand your exposure to supply chain vulnerabilities. That's again more infrastructure you need to maintain. You need to store. You need to generate those files and store those files for a period of time. EASeJ does that for you and stores them for up to 12 months after you've undeployed the application. Maybe you've got a security report showing CVEs in your pipeline tooling. Again, EASeJ we manage all that infrastructure for you, so we will fix those vulnerabilities. Maybe you've got security reports if you're using containers. In those containers, it might be your OS layer, your Java layer, it might be the runtime, and you need to maintain those things. EASeJ manages all that infrastructure for you. Just as a quick example, I'm coming across a growing number of customers who have chosen container routes, and their development teams are not maintaining those containers. They didn't used to be responsible for maintaining that infrastructure. They're not set up to maintain that infrastructure, and that is becoming a challenge for the platform teams. Ensuring application scalability. Maybe you need new infrastructure in order to run applications, scale applications out. That's all part of EASeJ. We make it very, very simple, as you saw with the kind of min instances, max instances. And then lastly, ensuring availability and scalability and resiliency. Well, that's all built into EASeJ. We automatically deploy the instances across availability zones for high availability. We have a 99.95 SLA, and as I said, we do the rolling update for applications, so you can continue to be available as you roll new features out. Okay, so if you like what you've seen in terms of EASeJ, feel free to visit the EASeJ site, and you can register your interest there, or you can talk to your sales representative about how to find out more and engage with us. So thank you very much for your time. Are there any questions? I don't know if there's any questions.
Hey, Graham, there was one question in the chat. They asked, do you have a solution for certificate lifecycle management of Java applications running in containers on OpenShift?
Yeah, I need to check with the team on that. I think that's either I think that's something that has been discussed.
So Graham, I did just post an answer in the chat.
Oh, okay.
With a link to some information on the Liberty operator, which I believe does help with that. So hopefully take a read of what I've posted, and if that doesn't answer the question, please do come back to us.
Yeah, so EASeJ, so we have certificate lifecycle as part of the Liberty operator. That's if you're in a Kubernetes environment. That's what we will leverage under the covers as part of EASeJ in order to manage the lifecycle of certificates. And I'm just not sure kind of what the final answer there is. Yeah. So there's Biff's asked is there a notion of workload management that will scale the instances up and down? Yes, so we automatically do that. So in the environment YAML, there was a min instances and a max instances that you could specify. So that helps you constrain your costs, if you like. But what we do is we automatically provision min instances, and then based on utilization of those instances, we'll scale up. If we find that those instances are being heavily used, or if they stop being heavily used, then we'll scale back down. So we will dynamically scale within those bounds that you specify. Okay, I don't see any more questions. Okay, so thank you for joining us and sparing the time. We appreciate it.
Perfect. Thank you, Graham, and thank you, Louisa. Wow, what a great way to start off the day. Thanks for the questions in the chat. Love to keep this interactive. Please, just a reminder, office hours will be at 2:30 Eastern time, so join us back then if you have further questions or if you didn't get the answer that you were looking for in the chat. That way you can come off of mute and actually carry on a conversation with many of our speakers throughout the day. So really appreciate it. Just a quick reminder, please take the survey and provide us some feedback from the session before you move on to your next session. And I see Pedro pasted a link for the Tech Exchange community to stay in touch. Otherwise, we will see you throughout the rest of the day and into tomorrow. Thank you so much, Graham and Louisa, again. Great new stuff and a continuation of the net new content that I'm so excited about personally, and hopefully you guys are getting some great information out of as well. Thank you so much, and we will see you in about 5 minutes in the next